Welcome to Programming Fluency. This is Section 4.3, Scope, Lifetime, and Storage. You now know how to write and call functions. In this video, we ask two questions. Where can a variable be seen? And how long does it live? Let's begin. We ask two questions. Where can a variable be seen? And how long does it live? The answers are called scope and lifetime. Let's find out what they mean. This is the plan for this video. First, we start with local scope. A variable declared inside a function lives inside that function, and no other function can see it. Next, we look at block scope, which is even narrower. A variable declared inside a pair of braces only lives there. You will also see what it means to shadow a name. Then we cover global variables. A global is visible everywhere in your program, and you will learn why that is usually a dangerous choice. After that, we separate two ideas that sound similar: scope and lifetime. Scope is where a variable can be seen. Lifetime is how long it lives. Finally, you meet static locals. This is a local variable whose value survives from one call to the next. Look at this program. There are two variables called result. One lives in the function square. One lives in main. They have the same name. Do they collide? Does square's result overwrite main's result? The answer is no. Each result is independent because each exists only inside its own function. The rule that makes this work is called scope. This is the first level of scope, local scope. A variable declared inside a function is visible only within that function's body. No other function can see it, read it, or change it. It is created when the function is called and destroyed when the function returns. Every variable you have declared so far has been local. Local scope is what keeps a function's internal variables private. This is a program with three functions. Each one has its own variable named x. Let's look at them one at a time. First, main. It has a local variable named x here. X holds 42. Next, function A. It also has a variable named x, but this x holds 10. It is a completely separate variable. And function B has its own x2. This one holds 99. Three boxes, three separate x variables. The name is reused, but each x lives only inside its own function. They never interfere with each other. This is what local scope prevents. This code tries to print secret from main, but secret exists only inside set value. By the time main tries to use it, secret does not exist. It was destroyed when set value returned. The compiler reports an error. One more thing, parameters are local variables too. The parameter in square is private to square. You cannot reach it from main or anywhere else. Local scope applies to whole functions, but C has a finer level, block scope. A variable declared inside a block, a pair of braces, is visible only from its declaration to the closing brace. This applies to blocks inside if-else, loops, and standalone braces. In this example, absolute is declared inside the if block. Try to use it after the closing brace, and you get a compiler error. The variable is out of scope. You have been using block scope since the loops chapter, without knowing the formal rule. The variable I declared in a for header exists only inside the loop body. After the loop ends, I is gone. That is why you can write two for loops that each declare int I. Each I is a brand new variable that lives and dies within its own loop. Blocks can nest inside other blocks. When an inner block declares a variable with the same name as an outer one, the inner one shadows the outer one. It hides it temporarily. So the output is 10, then 20, then 10. Inside the inner block, x refers to the inner x, value 20. The outer x, value 10, still exists. It is just hidden. When the inner block ends, the outer x is visible again. Shadowing is legal but confusing. Compile with -w shadow and use different names. So far, every variable has been local. C also lets you declare variables outside all functions. A global variable is declared at file scope. It is visible to every function below its declaration. It is created when the program starts and destroyed when it ends. And if not initialized, it defaults to 0. Here, call count is declared outside main and greet, so both functions can see and change it. Each call to greet increments the global counter. Globals seem convenient. Why not use them everywhere? Because they break the isolation that makes functions safe. Look at this. Two functions both change total. With 3 functions, this looks fine. But imagine a program with 50 functions across many files, all sharing total. If total has a wrong value, which function changed it? Every function that mentions it is a suspect. This is called action at a distance. The rule is simple. Prefer local variables and pass data through parameters where the flow is visible. Scope and lifetime are related but not the same. Scope is about visibility, where in the code you can refer to a variable by name. Lifetime is about existence, how long the variable's memory is allocated. Local variables have block or function scope, block lifetime, and default to garbage. Globals have file scope, whole program lifetime, and default to 0. Static locals have local scope, but whole program lifetime and default to 0. The static keyword is what separates scope from lifetime. This is the problem that static solves. You want a variable that persists across calls like a global, but is private to the function like a local. A static local variable is declared inside a function with the static keyword. It has local scope, so it is private to the function, but it has program lifetime, so it survives between calls. It is initialized only once, the first time the declaration is reached. Here, count is set to 0 once, and its value survives from one call to the next. Let's compare side by side. With static, S is declared static and starts at 0 once. Without static, S is a regular local, reset to 0 every call. Call each one 3 times. The static version counts up, 1, 2, 3. Its value survives between calls. The regular version is always 1. It is reset to 0 on every call, then incremented to 1. Same code, one keyword of difference, completely different behavior. Static local variables are useful in specific situations. Call counters, where you count how often a function runs privately. One-time setup, where you do something only on the first call, like print a banner. An accumulating state, like a running total or a unique ID generator. But do not overuse them. Static locals make a function stateful. Its result depends on how many times it has been called, not just its arguments. That is harder to test. Prefer parameters when practical. This is a practical use. A unique ID generator. Each call should produce the next number in a sequence. A static local is perfect. Last id starts at 0, initialized once. Each call increments it and returns the new value. Each call returns the next number, 1, 2, 3, 4. The value survives between calls because of static, and no other function can see or reset last id the generator is self-contained. A global would let any code reset it to 0 and break the sequence. Let's put it all together. This one program shows every kind of scope at once. We will reveal it piece by piece. At the outermost level is file scope. The variable global counter lives here, outside every function. It is visible to every function in the file. Inside the increment function is local count. It is a static local. It persists across calls, but it is private to increment. No other function can see it. The report function can see global counter because global counter is global. But report cannot see local count, even though local count is static. Inside main is the loop variable I. It has block scope. It exists only inside its loop and nowhere else. Watch report's view. Report can reach global counter. The green arrow shows global counter is in scope for report. But local count is out of scope for report. The red mark shows it is blocked. Static changed local count's lifetime, not its scope. Let's recap. Scope is visibility. C has 3 levels: local inside a function, block inside braces, and global outside all functions. Lifetime is existence. A local dies when its block exits. Globals and static locals live for the whole program. A static local combines local scope with program lifetime. It is persistent but private. Shadowing hides an outer variable with an inner one of the same name. Avoid it. And as a rule, prefer local variables and parameters. Use globals only with a clear reason. Next, you have built functions that call other functions. But what happens when a function calls itself? That is recursion.